All right, let's dive into the magic behind those incredible, interactive 3D experiences you see online. You know, the ones that run right inside your web browser. No plugins, no special downloads, just pure web power. So, how is that even possible? I mean, just take a look at this. This isn't some pre-rendered video or a screenshot from a game. This is a fully interactive, incredibly complex 3D model, and it's running in real time right now inside a totally standard web page. So that's the big question, right? How do we get from the web of simple text and images to, well, to this? To get the answer, we first have to understand the huge challenge that 3D on the web presents. See, at the very heart of all of this, there's this one core technology that lets a web browser talk directly to your computer's graphics hardware. It's unbelievably powerful, but there's a pretty big catch. And that technology is called WebGL. You can think of it as the ultimate gateway. It opens up a direct pipeline from a simple web page to the raw, number-crunching power of your graphics processing unit, the GPU. This is exactly what enables the kind of high-performance graphics that used to only be possible in dedicated apps and video games. But here's that catch I mentioned. WebGL is the engine, sure, but it's not exactly easy to drive. As the source material says, trying to build a 3D scene by speaking WebGL's language directly is, well, it's a nightmare. You're trying to manage vertices, shaders, matrices. It's a whole other world that's, frankly, way too complex for most developers. And this is where our hero enters the story. A brilliant piece of software that acts as a friendly translator, turning all those ridiculously complex WebGL commands into something a human being can actually understand and use. That hero, of course, is Three.js. It's a JavaScript library that basically hides all that nasty, low-level complexity. So instead of wrestling with raw WebGL, developers get to work with concepts that make sense, like scenes, cameras, and lights. It really does make the impossible possible. It was created by the legendary developer Ricardo Cabello, who's better known as Mr. Doob. And what he did was effectively democratize 3D on the web. He single-handedly opened the door for millions of JavaScript developers to start building these amazing 3D worlds without needing a degree in computer graphics. Okay, so how does it actually work? Well, every Three.js project, no matter how complex, is built from just a few core components. I like to think of it like you're setting up a play on a stage, and the first thing you need is the stage itself. Everything starts with the scene. This is your digital universe, your virtual stage. It is the container that holds everything you create. Every object, every light source, every single thing lives inside this scene. But hey, a stage isn't much use if nobody can see it, right? That is where the camera comes in. The camera is literally the audience's viewpoint. It defines exactly what part of that 3D world we're looking at, from what angle, and through what kind of lens. Now, what's really cool is that there are two main ways to see the world. There's the perspective camera, which is what we're all used to. It works just like the human eye. Things that are farther away look smaller. This is what gives you that realistic sense of depth and immersion. But then you've got the orthographic camera. It's totally different. It draws everything at the exact same size, no matter how far away it is. This is perfect for things like architectural drawings or even some cool, stylized video games. And here you can see that in action. This grid of cubes is being rendered with a perspective camera. You immediately get that sense of distance and scale, right? The cubes in the back are clearly smaller than the ones up close. It feels like a real space. Okay, so we've got our stage and our viewpoint. Now we need the actors. In the world of Three.js, any visible object, whether it's a character, a car, or just a simple cube, is called a mesh. And every single mesh is made from two essential ingredients. First up, you've got the geometry. This is the skeleton, the raw shape of the thing. It's the blueprint that says, hey, this is a sphere, or this is a complex car model. And then you have the material. This is like the skin or the costume that you put on that skeleton. Is it made of shiny metal? Is it a dull red plastic? Maybe it's see-through glass? The material tells the object how to react to light. You combine a geometry with a material and boom, you get a visible mesh. So we've got a static scene, which is cool, but let's be honest, that's kind of boring. The real magic of Three.js is when you start bringing these worlds to life. It's not just about showing things, it's about making them move, interact, and feel, well, real. One of the most powerful tools for this is skeletal animation. This is how you literally breathe life into a model. Inside this hand, there's an invisible skeleton of bones. By programming how those bones move, the outer skin, the mesh, deforms in a supernatural, realistic way. This is the exact same technique they use for character animation in blockbuster movies and AAA video games.
But what about getting objects to actually interact with each other? Well, you can integrate helper libraries, like PhysAS, to add a full-blown physics engine to your scene. And suddenly, your objects have mass. They obey gravity. They bounce. They collide. They create chain reactions, just like these dominoes. And the best part? You don't have to calculate any of that math yourself. The physics engine handles everything.
And for true immersion, what you see has to match what you hear. Three.js also supports spatial audio, which lets you pin a sound source to an object in your 3D world. As you move closer to that object, the sound gets louder. If it's on your left, you'll hear it more in your left ear. This is the kind of detail that tricks your brain into believing you are actually there. So, when you put all of these pieces together, what's the big picture? Why is a library like Three.js so revolutionary? Let's kind of zoom out and wrap this up. The impact is just massive. Three.js took an incredibly complex, frankly intimidating technology, WebGL, and made it easy to use for a gigantic community of developers. This one library is the engine behind thousands of interactive websites, wild product configurators, amazing data visualizations, and full-fledged games. It is without a doubt paving the way for the next generation of the web, a web that's more spatial, more interactive, and way more immersive. Which really leaves us with one final thought. We've seen what's possible today with these amazing tools running inside the same browser you're using right now. As that browser gets even more powerful, and as technologies like virtual and augmented reality become more and more mainstream, that line between a web page and a world is just going to keep getting blurrier. So the only real question left is, what new worlds are we going to build next?